Welcome back to Designing AI-driven personal adaptive learning and relevance course. This video will talk about content-based filtering and collaborative filtering. I'll talk about two different filtering. It's not much used in the education space, but this can be borrowed from the related domains. We talked about macro adaptation, like where the next content or the next topic can be decided based on students' performance. Imagine Apple might have a bank of 100 practice problems or videos and everything, 100, thousands. When a student finishes task, how does the PET module decide which of those thousands should be shown next? Okay, imagine you have a system, student finished topic 1. We have a lot of topics ready. How does the PET decides which topic to show next? Think about it and think about anything which you have seen similar in other domain, and pass this video, write down. After writing, please continue. One solution can be manually create a rich linear sequence. For example, hey, problem 1 is done, then problem 2, then problem 3. There should be a fixed order, structured. That's perfectly all right, that's where it works very well. But we could have a dynamic recommendation engine which has already been popular in other domains. Let's see one of them. In a content-based filtering, you can recommend a new item based on the similar items of users successfully engaged in the past. For example, if you have watched a particular set of movies in a Netflix or Amazon Prime or any other OTT, the system would recommend a similar, similar movies started recommending. It is very well in the YouTube. You started watching set of YouTube videos based on the particular features in it. It tries to give feedback. Similarly, if a student is successfully learns best with the visual geometry problems featuring high difficulty audio ins, and the system will recommend similar visual audio problems in the future. If you are able to succeed it, system can recommend it. To do this, what we need to label each and every item in the path with a very detailed labeling. These are some of the labels we can consider. Think about it. It can be topic. What are each topics, the difficulty level of the topic, the media type. Is it text or audio or the video? All those things as examples. Also cognitive skills. Is it easy? Is it a recall level? Is it apply level? What is the cognitive skill required for this level? It can be tagged. You can tag more tags. If you label everything with the proper tagging, then the system can match. That is one of the possible way to provide a content-based filtering. What it does it based on your previous likings, based on your previous interest. It makes a previous performance on that. It provides you the content. That is the content-based filtering. But there's a challenge in the sense content filtering is very great at specialization, like I want to give based on this feature, but it cannot give exploratory content. For example, I watched 3 videos, I got a new special content, but I want to explore, it will not let you explore, which means if you started watching set of some kind of videos, you will be fed into same kind of videos and you will go into that particular bubble. You cannot understand a different viewpoint out of these videos. That happens to most of us when we go to social media, be it Instagram and the YouTube or anything. Started watching it, the algorithm feeds you the same kind of data again and again and again. You'll be part of that particular bubble. You will not explore, you will not get the alternate view, you will not even see what is outside happening. You always think this is the one way to do it. So if the system serves up to the same problem. For example, if a student likes it, a particular kind of a problem, the system might put you in a loop and it gives you the same side of visual problems and everything. It will never give a different type of problem. It will never help you to develop a new skill which is needed in the next set of content. That is the problem. It will keep you in a bubble. It will teach you only with simulations. But not all the content, not all the topics will be taught with the simulation. So what you will do, you don't have content maybe. So what you will do, That's the issue in this particular challenges in this content based filtering. I hope this is clear in the content based filtering. We see what is collaborative filtering. So, whereas in the content based filtering, I think if you go consider the content based filtering, there is a user, okay. The user label 1, label 2, label 3, label 4. User likes label 1 and label 2, 3. Then the next content also would be trying to match the same label. Okay, this is the content 1. Let me put it this way. Content 1, user likes it. The content 2, user does not like it. Okay. So, the system recommendation, the recommended content will be it will tries to match the content which has either of these things, this is the recommended content. So, based on your liking and your performance, it can recommend the content. That is a content based filtering. Let us see the collaborative filtering. Instead of you like the content, let us go to the crowd. For example, what other people's like you or your friends like it, then let us recommend that content. If you go to Amazon, if you buy a couple of items, it says that customer bought this item, also bought this other item. So, would you like to purchase? Like for example, if you buy any item, it says as a recommendation system. It's a collaborative filtering. It looks at what are the type of items you are buying. Whoever bought a similar item puts all in the same group. It's all one group. These group of people who like this base item, so recommend it. So it's called, it based on the association rule mining. It's kind of trying to get you the recommended product based on your friends or the similar set of people as used system, same people. So collaborative filtering is the behavioral data of all other previous learners have used it, then guides you the current learner based on the content they liked it. For example, if a student A and student B have similar learning trajectories, for example, student A and B have same group, same area, same contextually same, and they are also have the similar kind of topics they learned before. And student A's future success to predict students B's part. For example, students A's performance and everything, we could use it to detect the students B's recommendation. For example, student A has done similar thing, student A liked a particular content in the other topic, we can recommend the same content to student B, they will also do well. The PAL groups mathematically based on the history, the right answers, wrong answer, the int request. Then the system need to know, feedback to them. That's the second idea. The PAL can be grouping this and giving feedback. The system does not need to know why the math problem is hard or why this is the math problem. You should know that 80% of students in your group fail it, so I should not recommend this problem to you. Okay. It's no need to tag the problem as hard or difficult, no need to tag the problem as cognitive skill or not, it's recall level. Instead, it has to know how many people succeeded or not succeeded. Is it clear? In collaborative filtering, the simple idea is this. Suppose, I think it's very much used in the shopping cart, in the in the Walmart example, but let me go, it's called association rule mining. So, user 1 so the content 1, content 2, content 3, content 4, content 5, content 6. Okay. So, these are the recommended content. Okay. Consider this. User 1 and user 2 likes this content. User 1 likes, don't like the content. User C did not watch the content. He also did not watch the content. User 3 whereas did not like the content, consider this example something. Now, next user 1 liked a content, some other content like C7 or recommended content. User 1 liked the new content. The system was most likely to recommend the same content to the learner. The sense the learner, user 1 and user 2 have the same preferences on the video liking and dislike. So I would recommend, based on the previous history of the similarity between these two group of learners, that is user 1 and user 2, I would recommend the same content to the learner 2. Whereas user 3 is not having similar thing, I would not recommend. I will try to find the other set of learners who have a similar, liking or similar performance or similar behavior pattern with other groups, then give content based on that. That is the idea of a collaborative filtering. Here, the collaboration filter is based on what others or the similar people brought it together, or others they preferred content, it provides the recommendation. This is a collaborative filtering. In a product collaborative filtering, if A and B are in the same struggling group, A is shown a textual hint and fails, and A is then shown a video explanation and achieves a mastery. Okay, the both students are the same group, and we know that A is not doing well in the textual hint and it's failing, but when it show video is able to do well. When the student B's have the same problem, instead of showing the textual hint, the system would only give you the video explanation immediately. No need to even give the textual hint. Is clear? So consider both student A and student B in the same group, and with the A, the system tested. We see that A likes the video compared to the textual hint. Since I know A and B are behavior the same, I will give the same video to the B instead of giving a textual hint. That's the idea. So that is a collaborative filtering. This will solve the problem of labeling a lot of things, also keeping in the same bubble of one particular loop, which can go to different trajectory. It's possible in the collaborative filtering. But the collaborative thing have a cold start problem. If the content is new, nobody has been liked it, nobody has done it, what can you do? If the student is new, we don't know students' preferences, we need to let the students fail for a few times, then you provide a content, right, to match the learner's behavior. We don't know the students' liking, the student whether perform well in the video or the text, the student will which type of mistakes he make. If we don't know the student, we need to let the students to perform for some time, then find a matching group, then provide a content. If the content is new, again the same problem will start. So the one recommendation is, can we combine both and make a hybrid recommended model? That is the idea. It's recently evolving. Okay. So most of the systems you use, whether Amazon Prime, Amazon Shopping Cart, or the Netflix, it's all hybrid model. It's not a one model, and they're more advanced in the terms of not one of a tag. Instead, the contextually, based on the location you are doing, based on the preferences for a long time, and your other searches in the cookies, everything is used to provide a feedback. This is changing now, but the basic crux is we could provide a feedback based on your peers liked it, or you could based on the content based on your preferences in the particular type of content. That is also possible to create a recommendation content. However, telling all these things, there is not any systems we know that uses collaborative content based filtering in the ITS or the PAL. So yeah, I think we are not aware of it. If any other system will be interesting to know. Thank you.